cold potato has 8 times more gut-feeding fiber than the same potato eaten hot. Same potato, different temperature, completely different food for your microbiome. That is not a diet trick. That is basic biochemistry. And it is one of 15 things on this list that most people eat every week without knowing what they are actually doing. Your gut microbiome is running your immune system, producing your mood chemicals, and managing your body's inflammation levels right now. Most people are feeding it almost nothing. The bacteria that matter most, the ones linked to lower inflammation, better metabolic health, a more stable gut wall, eat one thing: fermentable plant fiber, not supplements, not powders. The real compounds in real food that most people already have access to and are not using correctly. Number 7 on this list is something you have probably been throwing in the bin. Number 11 grows in your lawn. And number 12, the cold potato, most people destroy the moment they reheat it the wrong way. Today, 15 prebiotic foods, how they actually work, and exactly how to prepare each one so you do not waste what makes them valuable. Before we get to the food, you need to understand what you are actually feeding. Your gut microbiome is roughly 1,000 different species of bacteria, fungi, and archaea. Think of it as a dense rainforest living inside your large intestine. When that rainforest is diverse and well-fed, it produces compounds called short-chain fatty acids. The clearest thing I can call them is the gut's internal currency: butyrate, propionate, and acetate. These molecules do everything from dampening inflammation to telling your brain you have had enough to eat. Prebiotics are not bacteria. They are the food that bacteria eat, specifically plant fibers and resistant starches that neither your stomach nor your small intestine can break down. You pass them along intact, and your microbes ferment them in the large intestine, the colon. That fermentation is where the short-chain fatty acids come from. The research literature is clear on this. Microbiome diversity correlates with lower rates of systemic inflammation, improved insulin sensitivity, and more stable mood regulation. Evidence is also accumulating around the gut-brain axis, the direct chemical highway between your intestinal wall and your central nervous system. The 15 foods I'm about to walk you through are ranked loosely by the strength of their evidence and their ease of access, not by how exotic they sound. You have probably had most of them in your kitchen already and not known what they were doing. Garlic has been used medicinally for at least 5,000 years, but the reason it belongs at the top of a prebiotic list has nothing to do with its antibacterial reputation. The relevant compound here is fructooligosaccharides, call it FOS for short. It is a specific type of fermentable fiber concentrated in garlic's flesh. Your stomach leaves it completely alone. It arrives intact in your large intestine, where bifidobacterium and lactobacillus species treat it like a buffet. Clinical studies on FOS supplementation indicate selective enrichment of beneficial bacteria, specifically the bifidobacterium genus, within 2 weeks of consistent intake. The shift is measurable. What is interesting is that you only need 1 or 2 raw cloves daily to see a meaningful contribution to that FOS intake. Raw matters here. Cooking for extended periods degrades a portion of the FOS content. A quick sauté, under 4 minutes at medium heat, preserves most of it. Crush before cooking to activate the allicin, then let it rest for 10 minutes before heat touches it. A note from the nursing ward: if you are on blood-thinning medication, have that conversation with your prescriber before dramatically increasing raw garlic intake. The antiplatelet activity is real and documented. For everyone else, it is one of the cheapest prebiotics you can put on your plate. The hidden gem of this list, Jerusalem artichoke, also called sunchoke, is not related to the artichoke and has nothing to do with Jerusalem, but it contains the single highest concentration of inulin of any commonly eaten food. Published analyses place the range at roughly 14 to 19 grams of inulin per 100 grams of raw tuber, depending on variety and harvest timing. Inulin is the prebiotic fiber. It is what most commercial prebiotic supplements are trying to replicate. The compound is a long chain of fructose molecules that arrives at your colon completely intact and feeds bifidobacterium specifically. Studies suggest that consistent inulin intake is associated with measurable increases in bifidobacterium abundance within 14 days. The practical caution: if you have never eaten sunchokes before, start with a very small amount. A tablespoon of raw shaved sunchoke on a salad. The fermentation produced by inulin is vigorous enough that for most people new to it, the gas production is significant and uncomfortable. This passes as your microbiome adjusts over 1 to 2 weeks. Some people call it the fartichoke. That reputation is earned. Cooking softens the blow considerably. Roasting converts some inulin to simpler sugars, reducing the fermentation intensity while retaining a meaningful portion. Roast at roughly 200 degrees Celsius for 25 minutes, skins on, with olive oil and coarse salt. Onions share the same FOS and inulin content as garlic, but they also bring quercetin, a polyphenol compound that acts on the microbiome through a second, separate mechanism. Polyphenols are not fibers, but they modulate which bacterial species thrive by functioning as selective antimicrobials. They tend to suppress pathogenic species while leaving beneficial ones largely unaffected. The outer layers of a raw onion have the highest quercetin concentration. This is important because most people trim those layers away. The papery, brownish-purple skin just beneath the dry outer husk is edible and can be simmered in broths. Do not throw it away. Evidence from human intervention trials indicates that onion intake, particularly of raw onion and raw onion skin extract, selectively promotes bifidobacterium and lactobacillus growth in a dose-dependent manner. Daily intake of half a raw onion provides a clinically relevant prebiotic dose of FOS. A practical note: yellow onions contain more quercetin per gram than white onions. Red onions contain more anthocyanins, a secondary polyphenol. For prebiotic fiber content, all 3 species of common onion are broadly equivalent. Use what you grow or what your market sells locally. Leeks are gentler than onion, gentler than garlic, and significantly more tolerated by people whose guts are still sensitive or recovering. They contain the same FOS and inulin backbone as the other alliums, but in lower concentrations, which makes them an ideal entry point if you are new to prebiotic eating or prone to digestive distress. The green tops of a leek are where inulin concentrates. Most recipes throw them away because they are fibrous. That is the wrong approach for microbiome work. The dark green tops, chopped and simmered long in a soup, soften enough to eat and contribute a meaningful prebiotic load. In clinical nutrition literature, leek-derived inulin shows the same bifidobacterium selective enrichment as its allium relatives. The difference is practical. The gentler dose makes compliance more sustainable for the majority of patients I worked with who struggled with chronic bloating. Start here if garlic and sunchoke are too aggressive. Asparagus contains between 2 and 3 grams of inulin per 100 grams, less than sunchoke by a wide margin, but it comes alongside a suite of other beneficial compounds, including saponins and flavonoids, making it a broader spectrum prebiotic food rather than a single mechanism one. Evidence from ethnopharmacological and clinical literature indicates asparagus consumption supports the growth of lactobacillus, which plays a key role in producing lactic acid, the compound that keeps the gut's internal environment slightly acidic and inhospitable to several classes of harmful bacteria. Think of it as the microbiome keeping its own pH in check. The key practical note: cooking asparagus does degrade some of its inulin. Steaming lightly, 3 to 4 minutes, retains the most, while boiling in large volumes of water loses a measurable percentage into the cooking liquid. If you boil, use that water as a broth base. Do not let it go down the drain. Beta-glucan is the prebiotic fiber in oats. It is a different structural class from inulin, a long-chain glucose polymer rather than a fructose polymer, and it feeds a partly different set of microbes. Notably, it selectively increases the relative abundance of Akkermansia muciniphila, a bacterial species that research increasingly links to healthy gut barrier integrity. Akkermansia is worth pausing on. It lives specifically in the mucus lining of your intestinal wall, not in the gut contents themselves. It feeds on mucins, the molecules that form that lining, and this interaction appears to stimulate the host's own mucin production, keeping the mucosal layer thick and intact. When Akkermansia abundance is low, that layer thins. A compromised mucosal layer is associated with what researchers call intestinal permeability, a condition where the gut wall becomes more porous than it should be, allowing bacterial fragments to pass into the bloodstream. Beta-glucan from oats feeds the microbe that maintains the wall. 3 grams of beta-glucan per day is the threshold referenced in clinical literature for measurable effects on gut microbiota composition. A standard 40-gram serving of dry rolled oats provides roughly 2 to 2.5 grams. Steel-cut oats provide slightly more per gram of grain. Instant oats, which have been processed more aggressively, provide meaningfully less. A larger serving of around 60 to 70 grams gets you to the 3-gram target from oats alone. A preparation note: soaking oats overnight before cooking increases resistant starch content as the starch partially retrogrades during cooling. This is a secondary prebiotic effect on top of the beta-glucan. Soak, cook, and eat warm, or soak, refrigerate overnight, and eat cold the next morning. Both approaches are valid. The cold method produces more resistant starch. The counterintuitive entry on this list: a ripe yellow banana is a fast-digesting sugar source with minimal prebiotic benefit. The same banana, while still green, is a significant source of resistant starch type 2, a starch your digestive enzymes cannot break down, which passes intact to the colon and feeds microbes exactly as inulin does. The resistant starch content of a green banana varies depending on exactly how unripe it is. Published figures range from roughly 4 grams per 100 grams for a just-turning banana, up to 15 to 18 grams for a fully green one. As the banana ripens, those starches convert to simple sugars, and the resistant starch content collapses. A very ripe banana may have under 1 gram per 100 grams. The physical transformation from green to yellow is the resistant starch disappearing. Eat them green to feed your microbiome. Eat them ripe for a quick fuel source. Different food, same fruit. Green bananas can be sliced thin and eaten raw in salads, or cooked. Boiled green banana is a staple in several equatorial food traditions. Cooking a green banana reduces the resistant starch modestly, but still leaves a meaningful prebiotic contribution. Green banana flour, dried and milled unripe banana, is also widely available and can be added to oatmeal or baked goods. Preliminary observations suggest that green banana flour supplementation at around 15 grams daily produces measurable increases in butyrate-producing bacteria within 4 weeks. Chicory root is the reason commercial prebiotic supplements exist. Most products sold as inulin or FOS supplements are derived directly from chicory root extract. Published analyses of dried chicory root show inulin content ranging from 15 to 48% by dry weight, depending on the variety and harvest season. Still the highest concentration of any plant that is practically accessible for food use. Roasted chicory root brewed as a coffee substitute has a long tradition in European folk medicine and in regions where coffee was unavailable or unaffordable. Importantly, the roasting process does degrade a portion of the inulin into shorter fructooligosaccharides chains. These shorter chains are actually more rapidly fermented, meaning chicory coffee hits the colon faster and begins producing short-chain fatty acids more quickly than the raw root would. Neither form is inferior. They work on slightly different timelines. A practical note: because chicory root's inulin concentration is so high, dose loading can cause significant digestive discomfort if you are not yet adapted. Start with half a teaspoon of chicory root powder in warm water or broth. Build up over 2 weeks. The fermentation intensity is real. Your microbiome needs time to scale up its processing capacity. Lentils are a dual mechanism prebiotic. Raw and cooked lentils contain resistant starch type 1, starch physically enclosed within cell walls that digestive enzymes struggle to reach. When cooked lentils are then cooled, A second form, resistant starch type 3, develops as the starch molecules retrograde. On top of that, lentils contain a class of fibers called galacto-oligosaccharides. These fiber types feed different populations of gut bacteria, making lentils one of the few single foods that meaningfully contribute to microbiome diversity through two separate pathways simultaneously. The resistant starch formation in cooled lentils is important. Hot lentils have significantly less resistant starch than lentils that have been cooled to room temperature, then refrigerated for at least 12 hours. The cooling process causes the cooked starch molecules to realign into a tighter crystalline structure, a process called retrogradation, that your digestive enzymes then cannot break. Reheat them gently, and the resistant starch largely survives. Boil them aggressively again, and it dissolves. Studies suggest that regular legume consumption, including lentils 3 to 4 times per week, correlates with significantly higher gut microbiome diversity scores compared to legume-free dietary patterns. This is one of the most consistent findings across population-level dietary microbiome research. The effect size is larger than almost any other single dietary intervention studied. Flaxseed is included here for a fiber class called mucilaginous fiber, a thick, gel-forming soluble fiber that behaves differently from either inulin or resistant starch. When flaxseed meets water, it produces a viscous gel coating. That gel moves through the gut slowly, prolonging fermentation time and changing the physical environment in which bacteria operate. Evidence from clinical trials indicates flaxseed consumption supports the growth of a broader range of butyrate-producing bacteria than inulin alone, suggesting its gelation mechanism feeds species that inulin fibers do not reach. Flaxseed also contains a specific class of polyphenols called lignans, which appear to have an additional modulatory effect on microbiome composition independent of the fiber. Whole flax seeds pass through the digestive system largely intact. For prebiotic benefit, you need them ground. A coffee grinder set to medium coarse gives you enough surface area for fermentation without turning them into paste. Store ground flax in an airtight container in the freezer. The oils oxidize quickly at room temperature, and the prebiotic quality degrades. 1 to 2 tablespoons of freshly ground flax daily on oatmeal or in a smoothie is a practical protocol. You have been pulling these out of your lawn. Stop. Dandelion greens contain inulin and FOS in their root system and leaf structure, and they are one of the most bitter greens available, which matters for gut health through an entirely separate pathway from fiber fermentation. Bitterness activates receptors called bitter taste receptors, TAS2RS, distributed throughout your digestive tract. Stimulation of these receptors triggers increased bile production and accelerated gastric motility. In practical terms, bitter compounds tell your gut to move faster and process more efficiently. They also appear to have a direct regulatory effect on gut microbial populations, though the exact mechanism is still being characterized by researchers. The prebiotic fiber content of dandelion greens is higher in the root than the leaf, but the leaf's bitter compounds and modest FOS content make it a valuable dual-action addition to the diet. Evidence is based on recorded ethnopharmacological use and preliminary observations in animal models. Controlled human trials specifically on dandelion's prebiotic mechanism are limited. What is well established is the inulin content and the TAS2R stimulation. Add raw dandelion greens to salads. They are bitter, so pair them with a sharp dressing of lemon juice and olive oil, which softens the edge. Sauté them briefly in garlic and olive oil. The garlic compounds and dandelion FOS work on the same bifidobacterium populations, a useful combination. Cold potato is one of the best documented resistant starch foods you can eat. The science is straightforward. A freshly boiled and still hot potato has roughly 1 to 2 grams of resistant starch per 100 grams. Cool that same potato overnight in the refrigerator, and the resistant starch content rises to approximately 8 to 12 grams per 100 grams. The same food. Very different impact on your microbiome depending solely on temperature at the time of eating. The mechanism is retrogradation, the same process we discussed with lentils. Cooked potato starch molecules, when cooled slowly, reorganize into a crystalline structure that digestive amylase cannot break. This resistant starch, type 3, then reaches the colon intact. Studies suggest retrograded potato starch selectively feeds butyrate-producing species, particularly Faecalibacterium prausnitzi, one of the most studied beneficial bacterial species for intestinal barrier function. Reheating to below 60 degrees Celsius, a gentle warm-through, not a full boil, preserves most of the retrograded starch. Potato salad, eaten cold or room temperature, is an ideal preparation. Frying or boiling the cooked potato a second time destroys the crystalline structure and collapses the resistant starch content back to baseline. Treat cold cooked potato with the same respect you would any other prebiotic food. Apples contain two distinct prebiotic compounds worth naming. The first is pectin, a soluble fiber found in the flesh and especially the skin, which ferments in the colon to produce short-chain fatty acids and selectively feeds bifidobacterium and lactobacillus species. The second is polyphenols, concentrated in the skin and seeds, particularly catechins and quercetin, which function through the same selective antimicrobial pathway we discussed with onion. The skin is not optional. The apple skin contains between 2 and 4 times the polyphenol concentration of the flesh. Peeling an apple for a child who tolerates the skin removes the majority of the microbiome active compounds. If you are working with someone who has difficulty digesting skins, briefly steaming the apple softens it without fully degrading the polyphenols. Studies suggest that regular apple consumption, with the skin, is associated with measurable changes in gut microbiota composition within 2 weeks, including increases in fiber-fermenting bacterial species and decreases in inflammatory-associated species. This appears independent of overall fiber intake, suggesting the polyphenols play a distinct role beyond the pectin fiber. Wild ramps are the most seasonal item on this list, available for roughly 4 to 6 weeks in early spring in the Pacific Northwest and across much of North America's temperate forest zones. They are an allium, related to garlic and onion, and they carry the same FOS and inulin profile as their cultivated cousins. What separates them is flavor intensity. Ramps are powerfully, almost aggressively pungent. A little goes further than garlic. From a prebiotic standpoint, the bulb of the ramp carries the highest FOS concentration. The leaf is usable and flavorful but contributes less prebiotic fiber per gram. Fermented ramp bulbs, pickled in brine, are a traditional Appalachian and Cherokee food preservation method. The pickling process does not destroy the FOS, it is acid stable, and the fermented ramp then provides both prebiotic fiber for your existing bacteria, and the brine carries a small but measurable load of lactic acid bacteria. If you are foraging ramps, please confirm your identification carefully. There are toxic lookalikes. Lily of the Valley and false hellebore share similar broadleaf profiles in the early spring and are seriously toxic. Ramps have a distinctive garlic odor when the leaf is crushed. If there is no garlic smell when you crush the leaf, put it down. The smell is the identifier. Barley closes this list for a reason. It contains the highest beta-glucan concentration of any grain. Published analyses of hulled barley typically show beta-glucan at 4 to 7% of dry weight, with some varieties reaching higher, meaningfully above what oats deliver. It also contains a substantial resistant starch component, making it, like lentils, a dual mechanism prebiotic. The beta-glucan from barley demonstrates the same Akkermansia supporting effect as oat beta-glucan, and meta-analyses of barley intervention trials indicate consistent reductions in several markers of intestinal inflammation at intakes of 3 to 6 grams of beta-glucan daily. Pearl barley provides less beta-glucan than whole hulled barley because the outer bran layer, where beta-glucan concentrates, is partially removed in pearling. If you can find hulled or pot barley, use it. The cooking time is longer, but the prebiotic content is meaningfully higher. Barley soup, barley porridge, or cold barley salad, all are valid preparations. The same retrogradation principle from the potato and lentil modules applies. Cooked barley cooled overnight generates additional resistant starch on top of its native beta-glucan content. A cold barley and roasted vegetable salad dressed with lemon and olive oil is one of the most prebiotic-dense meals you can build from a single grain. Before I tell you how to put all of this together, a word about pacing. If you currently eat a low-fiber diet and you add 5 of these foods simultaneously next week, you are going to be extremely uncomfortable. The bacteria capable of fermenting inulin and resistant starch are not yet present in large numbers in a microbiome that has been fiber deprived. You have to grow that population first. Add 1 new prebiotic food per week. Start with the gentlest options: Leeks, oats, apple with skin, lentils. Give your microbiome 2 weeks before adding the high-intensity prebiotics like sunchoke, chicory root, or raw garlic. This is not timidity. This is how you avoid failing at this because the discomfort drove you back to your old habits. The clinical literature on microbiome change is encouraging in terms of timeline. Measurable shifts in microbial community composition are detectable within 14 days of consistent dietary change. The composition at 6 weeks reflects your dietary pattern substantially more than your birth microbiome. You are not locked in. The microbiome is genuinely responsive. One final note on diversity. The research suggests that eating 30 or more different plant foods per week, including vegetables, fruits, legumes, grains, nuts, seeds, and herbs, is associated with significantly greater gut microbiome diversity than eating fewer than 10. This does not mean 30 large servings. A tablespoon of flaxseed, a sprinkle of mixed seeds, a slice of rye bread. Each distinct plant counts. Keep a loose tally. It is worth doing. The 15 foods on today's list are your foundation, not a ceiling. Think of them as the structures you build the rest of your weekly diversity around. Garlic and onion in almost everything. Oats or barley for breakfast most mornings. Lentils 2 or 3 times a week. A cold potato salad on the weekend. A raw apple with the skin every afternoon. These are not dramatic gestures. They are small, consistent inputs that compound over weeks and months. I spent 2 decades watching people reach for symptom relief after the problem had already taken hold. The gut is one of the few systems in the human body where the evidence strongly supports a preventative dietary approach, not as a replacement for medical care, but as a genuine foundation that can reduce the frequency and severity of the problems that drive people to need that care. These foods are not a treatment. They are maintenance. They are the difference between a well-tended garden and one left to erode. If this kind of research is useful to you, subscribe. We go deep on how specific plants interact with specific biological systems. Now, I want to hear something specific from you. The research on resistant starch sits with me because the same food, prepared differently, is biologically different for your gut bacteria. A hot lentil and a cold lentil are not the same food when it comes to your microbiome. Tell me in the comments whether that changes how you think about meal prep and leftovers. I read everyone.